So we've been working with rational numbers for a while now. In fact, everything that we've done so far were rational numbers. Today's topic is irrational numbers. So just in English, who knows what the prefix IR means? Joe?
Like on?
On or not. So these are not rational numbers. So from what you remember with rational numbers, and one of the main things about rational numbers is that they live someplace on the number line that you can find and you can put it where it belongs, right? So if that's a rational number, what's an irrational number?
A number that has no place on the number line.
Good. You can't find its place. A number like pi that the decimals go on forever and don't repeat is irrational. I can't say pi lives right here exactly on the number line. I can estimate it, I can approximate where it lives, but I can't say exactly where it lives. And that's what makes it irrational.
Or like algebraic, like letters, or those?
No, in algebra, letters just represent numbers. So if they represent an irrational number, I guess you could think of them as irrational. But the letters themselves are not rational or irrational. They just represent a number. All right, so one of the other things that we have to talk about is why I can't put it on a number line. Okay? Because there's the number, right? 3.14. So I'm going to put it on the number line. Here's my number line, and I'm going to show you why I can't do that. So here's 3 and here's 4. If I want 3.1, what should I break my, how many divisions will I need if I want 3 and 1/10, which is 3.1? Jimmy?
9 lines.
9 lines for 10 divisions. Okay? So 3.1 is right here. So far I got 3.1. What's the next number in pi?
4.
3.14, right? So the distance between 3.1 and 3.2, I'm going to divide up into how many divisions?
4.
10 divisions again, and I'll move over 4 of them. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll move over 4 of them. So right now I got 3.14 on my number line. Well, there's another decimal in pi.
You're supposed to be writing. You're supposed to be listening.
What's the next decimal in pi? Can you read it from over there, anybody, or do you know it? 3.14?
1?
5.
1, and then the 5.
Oh.
So 3.141. So now I have to take this space between 3.14 and 3.15 and divide that into tenths and move over one of them. It gets so, I physically can't do it in this space, but in reality, numbers or points on a line don't take up any space. So it could theoretically be done, but there's always another decimal point. So I can get closer, and then I can get closer, and then I can get closer, and then I can get closer, and I can get closer. On that one paper right there are 10,000 digits of pi. And it doesn't stop. So no matter how long I get closer and closer and closer and closer, I can't find where it lives on the number line. You could think of that as not making any sense. And that's another word for irrational. It doesn't make sense. It doesn't have a specific spot on the number line that I can say, yep, you live right there, buddy. That number would be rational. Pi is irrational. And that's not the only one. There's the golden ratio that is irrational. Anybody know what the golden ratio is?
Wasn't it that spiral that you showed us?
That was Fibonacci, but good try. The golden ratio is, if I could draw a perfect star, and I can't, but if I could make it perfect, meaning all the side lengths are the same, that's pretty darn good, but it's not perfect, I'm sure. If all the side lengths are the same, exactly equal to each other, and all the angles were exactly equal to each other, the golden ratio is a relationship of this side of that one triangle to the bottom of that triangle. And that's somewhere around 1.7. But again, it's a non-repeating, non-terminating decimals. So that's what we're going to talk about when we say our first definition of irrational numbers. They're non-terminating. So what do I mean by non-terminating? What does terminate mean? The Terminator. Anybody see the Arnold Schwarzenegger movie? What does he do to everybody? He kills them. So what do you think terminates means?
Kills.
Well, in a sense, it ends. He ends their life. So, Terminator...
Escalated quickly.
I know. I'm off the movie now. So non-terminating means that decimal never ends. So they're non-terminating and non-repeating. So there's no pattern that I can draw a bar on top of and say I'm done. Okay, so there's no pattern and it doesn't end. Those are irrational numbers. So you know pi, you know psi, which is the golden ratio, and now you know definitions. There's one more category, and this is the one that gets challenging sometimes. I'm going to do a pattern here, see if you can figure out what is missing. The square root of 2 is irrational. The square root of 3, the square root of 5, the square root of 6, the square root of 7, the square root of 8, the square root of 10, the square root of 11, the square root of 12, square root of 13, square root of 14, square root of 15, and square root of 17 are all irrational numbers. And that pattern doesn't stop. What is missing? What is this pattern? What do you notice? Look for a pattern and see if you can describe what's happening. Why did I skip very specific numbers?
Because those other numbers are rational?
Yes. So the square root of 1 is a rational number. The square root of 4 is a rational number. But what else do you notice from that? Why those numbers? Why are they rational and these are irrational?
Wait. Oh, because they're... No. I don't know.
Can I give you a hint? Anybody remember? Did we copy that in the back of your book? No, we didn't do that yet. Okay. So those numbers are what we call perfect squares. A perfect square is when you take a number, a whole number, and you square it. Okay, so 2 times 2, 2 squared is 4. So 4 is what we call a perfect square because it's the square root of 4 is 2. It's a whole number. So all of those ones, the square root of 1 is missing. The square root of 4 is missing. Go ahead.
It's because if you do it one way, then you could also do it another way.
So it goes back and forth, you're saying?
Yeah.
So 4 squared is 16, so the square root of 16 is 4.
Yeah.
Good. Those are the ones that are rational numbers. The whole number squared, so 1 squared is rational.
So those are irrational?
These are irrational.
And the 4 and 0 are rational?
Not 0. 1 is rational.
Yeah, 1 I mean.
4, 9 is rational, and
Yeah, because they don't go together.
square root of 16 is rational.
Yeah, they don't go together.
Okay? So that's the idea of rational numbers and now irrational numbers. I'm going to give you some time to write some of that down. We don't have a lot, so just jot some notes down. Definitely get this definition and this list, and then maybe make a note for yourself.